Good evening, everybody, and welcome to the March edition of the OWASP Netherlands chapter meeting. Again, we are online, and perhaps it will be the last time that we are online. We might also be in April, and there will be a vote on that later. We can choose to either go online again or switch back to physical meetings, the city of which yet to be determined, of course. So within the break between the talks, keep your eyes open for the voting in the comments of this channel. Before we start off, there's a couple of major events coming from OWASP that are, well, not just the Netherlands. And the first one, and no, it's not an April Fool's joke, is the OWASP Benelux Day conferences. The OWASP Benelux Day is a yearly event. It's usually in the last week of November. Unfortunately, the most recent November, we had a bit of a lockdown. So for that reason, we switched to the end of March, which is the last Thursday of March, 31 for the training, and the Friday after that, Friday the 1st of April, for the conference day itself. As you can see now on my screen, more information can be found on owaspbenelux.eu. That's www.owaspbenelux.eu. We have a full schedule for a day, so please, if you consider joining, subscribe. Next off, OWASP has a global AppStack each year, of multiple actually, and there's one virtually going on in, well, it was supposed to be in Dublin, but it's virtual, and it will be in June, the 6th to 10th of June. Registration is not free, but early bird registration is open. You can find more information on virtual.globalappsec.org. As you can see on the screen, virtual.globalappsec.org. Today we have two major topics. These are Steve Springett on the OWASP Dependency track and the OWASP CycloneDX, followed by Klaas Wijbrans on the software bill of material. Why is it, what is it, and what challenges do we have? But first, let us introduce you to two new OWASP projects that have recently been launched. And for that, our first presenter of today is Cyan. Cyan, the floor is yours.
Hi everybody. I see Irfan also joined. It's also Irfan's project, so I think we'll present this together. So we are starting a security champions guidebook on how to successfully implement the security champions community within an organization and how also to maintain it. I know it's something a lot of organizations want, and a lot of organizations struggle with it, with the initial setup, but also with the keeping it alive part. And based on personal experience of a security champions community I set up at ABN AMRO Bank, Irfan asked me if we could do this project together to help other organizations. We had a kickoff last week together with Irfan and Robin van Loon, who's also joining this project, and we kind of determined how we're going to approach this. So in the first phase, what we want to do is to have a research phase. So to research what other companies have done in regard to security champions initiatives, what worked, what didn't work, so we can base it on more than just our personal experiences. Of course, we want to include that in the piece, because for us, what we did worked, but doesn't mean it works for every type of organization. So if you guys know of any organizations who have a security champions community, or some who have tried to set it up, and even if they failed, we will be very interested in talking with them and finding out what the parameters were, what made it a success or not a success. So we can include that in our research. And after the research, we will start to write our paper and offer it for review to the community. Anything to add, Irfan?
Brilliantly updated, Sharon. Nothing bad from my side. I'm really excited to bring this to you guys, and a call out to you guys. If you want to help, if you can help, please do that as well.
Anybody have any questions on the project? No. if there are no further questions, then we'll continue the way we are setting it up now, and we will share more information as we go with you guys.
All right. If anybody has questions, please leave them in the comments on YouTube. There's a slight a slight delay between what we're saying and what you hear. So we'll get back to you with with answers. Well, somewhere during the presentation, they will be put in the chat as well.
Okay, great. Thank you.
Next on, a different project, and it's launched by Amit Sharma. Amit, go ahead.
Thank you so much. Hello, everybody. My name is Amit, and it is a great opportunity to be speaking in front of such Stephen Klaas as well, because our new project is also in line towards SBOM. Everybody knows that open source is no more or less risky than proprietary code. Failure to adequately secure it introduces greater risk to your organization. But the challenge that we saw is only few companies have much visibility into the open source they use, or even fewer can produce an accurate, up-to-date SBOMs. So basically, after the EO from the US government, it has become much more important, and maybe in the future, it is going to be the de facto baseline for all organizations to build. We saw that NTIA brings in what needs to be done, how we can help, and how it can be achieved. But what we were thinking was maybe we can actually identify and define some kind of use cases or things that might make it much more easier to do. Very much in similar lines of software component verification standards, and maybe how we can comply SBOMs with NIST standards in conjunction to the Executive Order 14028. So it is also in a very initial phase. Of course, the guidance from Stephen Klaas is definitely going to help us. We are still exploring on what needs to be done from objective perspective, in terms of how we can achieve these challenges, or how we can, overcome these challenges. And maybe, we are also inviting other people to contribute if there is any kind of information that is available, and make this a success. Thank you.
All right, thank you, Amit, for your introduction. Again, if you have any questions for Amit, or of course for Cheyenne, for the other project, please leave a message in the comments, and we'll answer them shortly. Next on the list is a presentation from Steve Springett. Steve Springett on the CycloneDX and Dependency track projects from OWASP. Let me enable the screen for that. Where is my, if I can find my mouse, that is a second. So here you go. Ladies and gentlemen, Steve Springett. Steve, the floor is yours.
Thank you so much for having me. I know we're all kind of itching to get back to in-person meetups when possible, but it's been interesting for me being able to speak at different places around the world without having to hop on a flight for 8, 12 hours or more. So it's been an interesting couple of years, to say the least. For those who are celebrating St. Patrick's Day or Holy, so there's a lot of stuff going on today. So happy St. Patrick's Day and Holy to you. What we're going to be talking about is CycloneDX and Dependency Track, both of which are OWASP projects, and they work together to achieve a lot of cybersecurity use cases. So real quick about me. I build stuff, I break stuff, I build stuff to protect stuff. I get paid to do stuff at ServiceNow. There's my contact information if you'd like to reach out. So we're going to be talking a lot about SBOM today. Well, we've been talking about SBOM for quite a while now, ever since the executive order in the US really hit. But my talk isn't necessarily about SBOM because a bill of materials or software bill of material is by definition a small subset of the problems that we actually care about. So we're going to be talking about a bill of materials and software being part of that in this conversation. The two projects that we're going to be talking about today, excuse me, is CycloneDX, which is a bill of materials standard. It is a flagship OWASP standards project, and it's used by many, many organizations. We're also going to be talking about OWASP Dependency Track, which is another OWASP flagship project, a tools project, and its job is to consume and analyze bill of materials such as CycloneDX. So real quick, just to kind of level set at a very, very elementary level. This is what a bill of materials is. If I want to make risk-based decisions, for example, if I have allergies to tree nuts, this might be something that I would care about. In the software world, we're not necessarily looking for the presence of nuts, but we might be looking for the presence of Apache struts. Here's a really interesting talk given by Alan and Frederick earlier this year. If you want to have a little bit of informative and entertaining session, this is a good talk to visit. And of course, Klaas is going to be talking a little bit about SBOMs as well right after me. So a lot of what we're talking about, however, was as a direct result of the executive order. And it's not like the US government tells everybody what to do, but the reality is that the US government has a really big purse. They procure a lot of software, and because of the expenditures, the amount of money that's allocated for software and other things, it has a really big impact on pretty much the entire software industry. So that's kind of one of the reasons why we're talking about that, and I know Klaas is going to be hitting that a little bit harder right after this talk. But let's dive into CycloneDX, which is that bill of materials standard. Again, it is a flagship OWASP project. It's probably unlike other OWASP projects that you might be familiar with. CycloneDX actually operates as a meritocracy, very similar to the Apache Foundation. We have different working groups. We have a formal governance process. We have a formal standards process. And we take a risk-based approach to standards development. The spec is highly focused on cybersecurity use cases, although there are other non-security use cases that we also support. And as part of our risk-based approach to standards development, we release yearly revisions of the spec, which are backwards compatible. It is recommended by multiple world governments, and it has a really big industry of adopters and supporters and vendors that support the spec. But it's not an SBOM standard. It's actually a bill of materials standard, and software is just one of the really important things, but it's just one of the things that it can actually represent. Software or SBOM is one, but we also support things like OBOM or operational bill of material, where I can represent not only the stack for my application, but I might want to represent the operating system or the hardware that operating system is running on, or the VMs and the deployment information of where it's running at. I might want to, if this application, for example, is an IoT camera or an IoT toaster for that matter, I can describe the full stack, including all the hardware, the device drivers, and everything else that makes a shippable product. I could also describe services. Software hasn't lived in a vacuum for 20 years. And the fact that we're talking about SBOM is nice. It's a good starting point, but it leaves out half of the equation, which is services. So not only can you describe services within CycloneDX, but you can have an inventory solely of services, which is a SaaS-BOM. This is actually a cloud security recommended practice. And you can also describe the vulnerabilities that is in my inventory of software, hardware, and services, and if any of these things are actually exploitable or not, which is, if I'm a consumer of software, That's actually what I care about, right? The inventory is nice to have, but as a consumer of software, I want to know what things I should worry about in my environment so I can protect those things. CycloneDX is used, again, by a lot of organizations. There's estimated 100,000 organizations using this in production today. And these are some of the projects and vendors that support the spec. These are just the ones that we know of. I'm sure there are many, many more. But interestingly enough, multiple world governments have come out in support of CycloneDX. And NCSC, right here in the Netherlands, was one of the first last year to actually come out in support of CycloneDX as their preferred format. So this it's an interesting read. I would highly encourage you to take a look at it. It has some really good use cases for SBOM that they go through and why they were leaning towards CycloneDX as their preferred format for this. So give this a read. It's interesting. CycloneDX, at its very core, going back to that very elementary use case, can describe a complete and accurate inventory. That's really the foundational use case. But we can also use it for vulnerability analysis, right? Once we know what the components are, great. Now I can actually analyze them for known vulnerabilities. That's a basic risk management use case, which is why the executive order was created in the first place. But we can also do things like integrity verification, right? Is my components, have they been altered since I actually got them from Maven Central, or maybe there was some malicious things in the transmission of that package to my environment. I can do integrity verification. I can actually analyze the software package itself. Does the project have maintainers? Does it have do they answer support tickets? Do they do, basic good practices, best practices when it comes to software engineering for their respective open source project? Obviously, cybersecurity isn't the only use case, but we can also analyze it for license and intellectual property use cases. CycloneDX can describe component assemblies, and I kind of equate this to like a dashboard in an automobile, right? A dashboard in an automobile might contain a instrument cluster. And within the instrument cluster, you might have a speedometer or tachometer. And within that speedometer, you might have plexiglass and LEDs and capacitors and all these things, right? And that exploded component hierarchy is what we call a component assembly within CycloneDX. It's a way to describe really, really complex component, software component architectures in an SBOM. But open source is the ultimate supply chain. Components can and will be modified, renamed, redistributed ad infinitum. And we can describe that component pedigree, the lineage of all of these changes and where they were derived from in my SBOM. And where you got that SBOM from is also really, really important. Did I get it from a public repository like Maven or NPM? Did I get it from a certain supplier, such as Microsoft or Oracle? Did I get it from a certain country that might have sanctions against it? I don't know. But provenance is a story of origin, and we can describe that in CycloneDX. And we can also describe our reliance on services, such as if I have a bill of material and I have a component within that bill of material, and maybe that component, for example, reaches out to grab stock tickers off the internet. Well, that component technically doesn't have any functionality by itself. It relies on a third-party service. I can include that service in my bill of material and that dependency relationship as well. And there's, of course, a lot of other use cases that you can do with CycloneDX. Really briefly, this is a lot of data, I know, but this is essentially at a very, very high level the object model of CycloneDX. At the top, we basically have the information about the bill of material and about the component, typically a software component, but could be a hardware component, about the component that the bill of material is for. In the blue, we can describe things like applications and frameworks and libraries, containers, devices, firmware, etc. We can describe the services and the endpoints, trust boundary traversals. We can also describe the type of data, the data classification, and the directional flow of data between component and service or between services. We can describe the dependency relationships. If one component depends on something else, no matter if it's a software component or hardware component or a service, we can describe those relationships as well. We can also describe the completeness of these things, right? If you're creating bills of materials in your build pipeline, you may not necessarily have complete 100% transparency of everything that you're including, right? So you can describe how complete you think this bill of material actually is. And there is no wrong answer, right? If you don't know, that's fine. You can actually state that in your bill of material. Likewise, if you're only including third-party components or including only first-party components, or if you think that the bill of material is completely complete, there's ways to specify that as well. You can describe vulnerabilities. CycloneDX is actually a bill of vulnerability spec as well. But you can describe the vulnerabilities affecting the software components, the hardware components, and the services within your bill of material. And you can describe the exploitability of those things, which is really what the end consumer wants to know in the first place. And finally, CycloneDX is extensible. There's a lot of different ways that you can extend it to do different things while still conforming to the specification itself. There's a lot of different ways to create SBOMs. I'm not going to go into all of them in detail. Here are some of the more popular ones, starting with SCA tools. This is kind of the easy button for a lot of organizations where you might have an SCA tool, whether it's commercial or open source. Many of them already support CycloneDX. If your vendor does not, please ask them to do so. If vendors want to be relevant in this space, they need to support SBOM. And CycloneDX is the leading SBOM format for cybersecurity use cases. So it's in SCA vendors' best interest to support this. But for the most part, this is an easy button because a lot of organizations already have this. However, SCA tools are not designed to describe complete and accurate inventory. They're designed to identify risk, which is why integrating bill of material creation into the build lifecycle itself is a really good option. You typically get a much more accurate representation of your inventory by doing this. But it does take a little bit more work. You can analyze a source repo for bill of materials, right? Not overly useful for most cybersecurity use cases. There are a few, but this is more for license and intellectual property use cases. This is really useful for those. You can actually create SBOMs at runtime, right? Through IAST or through, there's certain mobile platforms for iOS and Android that you can create dynamically from your device, a bill of material, not only of the components that your application is shipping, but the components, maybe the native components on that device that are actually invoked by your application. You can target the factories themselves. These are things like Jenkins and GitHub Actions and these types of things. So instead of integrating it with the build lifecycle, you can integrate it with the factory, and you may not necessarily have the most accurate results, but it's a really easy way to get a lot of results really, really fast. And there's still some ecosystems, C, and C++, for example, that still have practices dating back 30 years. And in those cases, they manually manage dependencies for the most part. In a lot of cases, they're going to have to manually manage their SBOMs as well, unfortunately. CycloneDX, the website, does have a lot of use cases and examples. Examples are published in both XML and JSON. JSON is the preferred format. However, I would also take a look at the XML examples. Not that I want you to use XML, but because XML as a format supports comments, it's actually easier, in my opinion, to actually look at the examples in XML because many of the XML examples do have comments, whereas the JSON ones do not. And finally, visit the CycloneDX Tool Center. This is a marketplace of free open source commercial tools that support the spec. I think we're up to close to 120 or so tools, both open source, commercial, etc., that support the spec. So if you're getting into SBOM for the very first time, check out the Tool Center. This is really going to save you a ton of time. In terms of participation, check out the website. We have our own GitHub organization. We also have our own dedicated Slack workspace. So most OWASP projects, they have a dedicated channel within the OWASP Slack workspace. We actually have our own dedicated workspace. This is one, for historical purposes, and two, our Slack is pretty big. We've got like 20 some odd channels just for Cyclone. So we have our own workspace as a result. We do technically have a mailing list, although there's not a lot of activity. It's really there to support those folks in government who just cannot get access to Slack because of policy. We're also on LinkedIn and Twitter if you want to follow us there. But now that we talked a little bit about bill of materials, I want to dive into, once you have a bill of material, now what? What do you do with it? That's really where dependency track comes in. So what does it do? It consumes, it analyzes, and produces bills of materials at high velocity. That's interesting. Which means it's ideal for use in modern build pipelines. But it's also good for procurement and M&A. If I'm purchasing a piece of software from a vendor, or maybe I'm purchasing a company, which is what I do in my day job. I look at these companies for various cybersecurity risks. It's really, really good for these types of manual use cases as well. It's designed to answer one question. What is affected? Log4j, and where? My application version 1.0. So if I'm an enterprise with tens of thousands of assets in my environment, I really, really care about this one fundamental question. What is affected and where? Conceptually, this is what it does. I have an asset. It could be a microservice, monolithic application, could be an IoT toaster, or even a thing like, I don't know, a server. I have an asset, I have a bill of material for that asset, and I continuously analyze it, and everybody's happy. Going down a few hundred feet, this is still at a high level. This is what it does. On the left, we produce the bill of materials. We can do this in a CI/CD pipeline, pretty easy. There's lots of tools that do this. You can get them from suppliers. However you get your SBOM, the next step is then to ingest it into Dependency Track. Dependency Track has an API first design, so you can use curl, you can use a Jenkins plugin. There's a bunch of other tools that you can use to upload to Dependency Track. And once it's in Dependency Track, it analyzes for security, operational, and license risk. And it doesn't wait for bills of materials to be analyzed, though. It's going to continuously analyze your inventory at a minimum of every 12 to 24 hours. I can't remember what the current cadence is. But every day at a minimum, your inventory is going to be constantly analyzed. But keeping all that data inside Dependency Track isn't really useful, right? You need to make risk-based decisions, more real-time risk-based decisions based on this data. So we have webhooks and a bunch of other things that allow you to get as much data as necessary to, one, understand what is affected, where is affected, and kind of the severity or importance of what it is that you need to do. That way you can perform certain types of automated actions as a result of your analysis. So with that, let's actually dive into a demo of Dependency Track and see what it's all about. So I'm going to stop sharing this and share another window real quick. And bear with me real quickly. Where's my other window? There it is. When you first log into Dependency Track, you're going to see a window that looks like this. You're going to see a nice little dashboard with time series metrics, and it's all, good and pretty and all that. Now, dependency track is kind of organized by projects. And a project could be, a project could be anything, really. It could be a microservice, monolithic app. It could be that IoT toaster. It could be an automobile, right? An automobile has, 20, 30 different software systems running at any given time. So a project is just a container, I guess, of inventory. And as you can see here, I've got, looks like 7 projects defined. And I can go into any of these projects. For example, I'll take the first one, and I can see my inventory of components, right? But I'm actually going to create a new project. And I'm going to do WebGoat just because it's an OWASP project, and we're at OWASP. So let's see. Oh, I can give it some tags. That way I can search for it in the future. Vulnerable by design. Yes. So I can create that project. And once I actually have created that project, I can go into my inventory and upload the bill of material. And let's see, where is it at? There it is. All right, so if I refresh this, yeah, I have 136 components in my inventory now. And it looks like I have some of which that have vulnerabilities. But over here, you've got the component name and version. You have an indicator whether or not it's out of date or not, or if it's the current version. If that component is, if that component's ecosystem supports grouping or scopes, you'll have that here. Whether or not that component is internal to your organization is here. The license, we support all SPDX license IDs. We have a basic risk scoring mechanism, and of course the vulnerabilities as well. Let me refresh this. Oh, here we go. I think I have to refresh the whole thing. Okay. If we go into the dependency graph part, we can also drill down to the transitive dependencies. For example, this is a Maven multi-module Maven project, so I can kind of drill down into my dependencies like this. Now, this is one way that we are representing dependency graphs today, but we're actually working on a few other ways to visualize our dependency graphs in the future. So if you have any ideas for that, let us know. But the primary purpose that we're all here for is to identify known vulnerabilities, right? It's great that I have an inventory, but I want to know what my risk is. So this is a way for you to kind of audit or triage the findings from the analysis. If you are familiar with Fortify or any other static analysis tool, this concept, this workflow is going to look really, really familiar to you. So let me just choose the first one here. I'm going to expand that. It gives me a title and description of what the vulnerability is. It has an audit trail. Oh, that's interesting. It allows me to make comments on this. For example, maybe I'm not actually exploitable to this. Well, I can make that kind of comment here. I don't think this is exploitable because I cannot spell today. And I can add that to my comment trail. I can also make analysis decisions based on this. So if I'm really not affected by this vulnerability, then I can mark it as such, and that becomes part of my comment trail. Now, we talked a little bit earlier about the concept of VEX, or Vulnerability Exploitability Exchange. What I'm doing now actually is part of that. So if you are a software vendor, this is where things really start to get interesting for you. So I can make my analysis decision, and if I'm truly not impacted by this vulnerability, I can go ahead and suppress the finding. That way, my metrics, time series, risk scores, etc., are not actually impacted by this particular vulnerability. Now, I have an ability to have a justification on this, right? I'm not affected by this because of, maybe the code is not reachable because I'm not using that particular method in this class, right? And then as a vendor, I can say what my response is going to be. I'm not going to update, right? So I'm not going to fix this because that code is not being reached. It's technically not exploitable, and I'm not going to fix it, right? That might not be the response that we would all like to have, but that's going to be a response that a lot of vendors will undoubtedly make. And then, of course, you can provide some details about workarounds or all kinds of other things after the fact as well. But this information becomes part of your audit trail and part of the VEX. So if you are a software vendor, this information you can provide your consumers. You can provide your consumers the bill of material of, in this case, WebGoat 8.0. You can also provide your consumers the VEX as well to tell them things that you are not exploitable to. If I had any policy violations, they would be here. I don't have any policy violations defined right now, so I'll get back to that in a minute. But just where I had the ability to upload the bill of material, I also have the ability to download the bill of material. So this actually dynamically generates a bill of material for you. It doesn't actually keep the one that I just uploaded because I can change it through APIs or through other means. But these dynamically create the bill of material for you on demand, and you can request the bill of material for just the inventory, or the inventory with the vulnerabilities, or just the VEX. The most common way that you're going to, if you're a software vendor, the most common way you're going to do it is you're going to provide your customers an SBOM of just the inventory and basically a VEX bomb, or just the vulnerability exploitability exchange without any inventory information. Those are the two files that you would typically provide consumers of your software. Now, everything I'm doing here in the UI can be automated, right? It has an API first design, and behind the APIs, there's a lot more functionality than what you see here in the UI. So I'm showing you the UI just because it's just a better demo. If I showed you something with GitHub Actions or Jenkins or something like that, it would just look like magic, and you would be done in like 5 minutes. But the manual use case is really interesting to look at because you see kind of the workflow, but it also kind of shows you how you might use this for procurement and M&A, where you're not actually building your own bill of materials. You're actually getting those from other vendors and using dependencies track to analyze the bill of materials that you're getting from these other vendors. Now, WebGoat, the bill of material for WebGoat doesn't have any services defined. I want to show you one. I think I have one. Yeah, I got a service example here. In this particular case, just for simplicity's sake, I have a single component. And that single component is this Java ticker client. And its sole purpose is to rely on this external service. And this is the ticker service. And if I go into the ticker service, it will tell me information about the provider, contact information. It will tell me the endpoints that this particular service has. It'll tell me the data classifications and the directional flow of data between that component and that service, as well as any external references for documentation, etc. So this kind of completes the whole holistic view of inventory, right? You can describe your components and your services collectively in your inventory, which is really important. But the primary use case was vulnerability management, and a lot of cases we might want to find, for example, the presence of Log4j, for example, right? We can search for things like Log4j. Do I have any here? Yeah, I got some Log4j in my environment. And again, if I have tens of thousands of assets in my environment, being able to very quickly know where I'm running Log4j, this is huge. In December, when this came out, many organizations were spending weeks just trying to determine where Log4j was running in their environment, let alone fixing it. With bill of material and things like dependency track, this is really like a 5-minute job. This is not hard at all. In fact, I think one of the financial services in this companies here in the US, Goldman Sachs, actually did a blog post a couple of weeks ago kind of highlighting that point. When Log4j happened to them, it wasn't really a big deal. They were able to use, because they use Cyclone, they use dependency track, they were able to find out where they were using Log4j and it, and spend most of their time fixing it instead of finding it. But you can also search for things the other way. So for example, I don't know if I have any, I don't know but I want to search for maybe like Jackson data bind vulnerability, right? So maybe I want to search for, if I can remember this, I think it's this one. Yeah. So if I want to search for this vulnerability right here, this is Jackson data bind vulnerability. It tells me a little bit about it, but it also tells me what assets, what projects in my environment are actually impacted by this vulnerability. This is huge. So as I'm watching the news and I hear about this new vulnerability of the week, I can now go into dependency track, type it in, and see what projects in my environment I'm actually affected by this thing. So this is a really big, important use case. But again, cybersecurity isn't the only use case that we support. We also support licenses. SPDX license identifiers are supported. We will be working on to expand our license support to include SPDX license expressions as well. So for example, something is licensed with this license or this license, or this license and this license. So we'll be working on expanding that in the future, but we have some basic license support today. But we do have policies, right? And a policy evaluation engine. So for example, if I wanted to have a policy that I wanted to fail all builds on for anything with Apache struts, right? That would be a really good policy to have, right? Maybe I don't want struts in my environment. That would be one way that I can actually accomplish that. But you can also do other things, right? You can do it based on severity of vulnerabilities. You can do it based on license groups. We have these things called license groups over here. They ship out of the box with some predefined ones, but you can change these to your heart's content, add new ones, change it all up if you want. Each one of these have a bunch of open source licenses already kind of defined in them. We had to rely on a lot of public information to be able to create these license groups. It's certainly not as comprehensive as you would expect to find from a commercial SCA tool with their own legal team, for example. We had to rely on publicly available information to have this kind of list. So if you do have your own legal team, you can certainly expand this to your heart's content. So you can define maybe I don't want any copy left in my environment. That would be one easy way to do it. Or maybe there's just one license that I really don't want in my environment. Maybe I don't want, I don't want this license, AGPL. I'm allergic to AGPL. So that might be something that I might have a policy on. But I can also do different types of component identities as well. Package URL, I can do it based on CPE. I can also do it on with tag IDs. The interesting thing, oh wait, what's this? All right, yeah, okay. I'm actually running an alpha version of the dependency track. So not only am I praying to the demo gods right now, but I'm like really crossing my fingers at the same time because this is like unreleased alpha quality software I'm demoing right now. But anyway, it does have a pretty robust policy engine that a lot of organizations take advantage of. And finally, it has a bunch of administrative controls. It supports different analyzers. It has an internal analyzer that mirrors the contents of the NVD, as well as uses GitHub security advisories. It integrates with Sonatype OSS Index, which is a free service from Sonatype. If you have a subscription to VulnDB from Risk-Based Security, it supports that as well. You can configure how you want the NVD mirroring to work. You can configure how whether you want GitHub advisories enabled or not, and then what is your personal access token for that. And for identifying whether components are out of date or not. It has to support a bunch of different repositories as well. And there's a number of different ecosystems already supported in here. My computer went to sleep. And, you can add them and change them. And, so if you have internal Artifactory, Nexus repos, etc., you can add them here. So that way you can determine whether your internal components, for example, are out of date or not. It supports a bunch of different notification and notification platforms. For example, WebEx, Teams, Slack, webhooks, etc. And then finally, we support LDAP, OIDC. We have an internal user management as well. I wouldn't recommend using it. Use OIDC would be my recommendation. But anyway, that's kind of dependency track in a nutshell. Let me switch back to the deck. I'm almost done here. And I'll take a little bit of questions at the end, I think. Let me share. There we go. So again, the dependency track site has its own website. It has its own GitHub organization. This project does use the OWASP Slack workspace. We have this hashtag dependency track project on Slack. I invite you to participate in it. It's pretty active. There's a lot of really good community members there, adopters, people are trying it out, etc. So it's a really, really great community of folks. We also have a Twitter account if you want to follow that as well. And with that, thank you so much for listening to me talk about Cyclone and dependency track for the last, 45 minutes or so. I appreciate it. If there's any questions, I'll open the floor for questions at this time.
All right, thank you, Steve, for this wonderful presentation. As Steve said, the YouTube comments are open for questions, and also if you have any questions for the previous introductions of the two new OWASP projects, you can use the same comments as well. Now on the poll, we have, as I stated on the start, the next meeting could either be virtual, online again, just like this one, or we could switch back to physical meetings. And the statistics at this moment are clearly in favor of an online meeting, with I think about all the viewers having voted by now. So basically the next meeting in April will also be online. It will be again on the third Thursday of the month. I'll tell you the exact day later on, and topics will be published shortly. Now, I think everybody grab something to drink, and in about 15 minutes, let's say 8:05, the next presentation will start. The next presentation is by Klaas Wijbrans about the software bill of materials. We'll be right back. And we have a question from one of our viewers. Ben de Haan stating that it's a very interesting talk. What is your experience on CycloneDX adoption with software vendors? Are you seeing any significant growth there? So Steve, any information on that?
I am seeing a lot of adoption. It's really interesting when you create something, how you think it will be used versus how it actually is being used. Because it has a lot of different capabilities, mostly security capabilities, there's some use cases and some vendors that are working on that are really interesting that I wouldn't have never thought of. So yes, it's being adopted by like SCA vendors and this type of thing. For example, you know, Grammartech and Sonatype, Sneaks in the process of adopting it. I mean, there's all kinds of Veracode. There's all kinds of vendors that currently support it, like in the SCA space. But once you get outside of SCA, things like contrast security, right? They can actually dynamically generate bill of material at runtime, which is pretty cool. Now Secure supports you know, mobile. You can do it dynamically at runtime. I'm seeing really interesting happenings in forensics. So being able to analyze the firmware on running devices, for example, and generate CycloneDX from there. I'm seeing CycloneDX actually being used in SOCs. So your security operations center, where they might use the CycloneDX bill of material as kind of a baseline of what that application is, both the inventory and the services that it should talk to, and then using that baseline to detect anomalies, right? So there's all kinds of really, really interesting things I'm seeing around CycloneDX. I'm also seeing a lot of innovation around distribution of SBOMs and signing of SBOMs, and even a marketplace of SBOMs for open source projects. There's just a ton of innovation happening in this space, and I think a lot of that innovation not only stems from the EO, right? Whenever the federal government says do this thing, you're always going to get a bunch of startups and whatnot doing that. But because of its focus on cybersecurity use cases, we're seeing a lot of really interesting things that weren't necessarily really planned for, really. I mean, people are looking at the capabilities of Cyclone and thinking, oh, I could also use it for X. So we're seeing a lot of innovation that we clearly didn't think of long ago when we started down this journey.
All right, that seems like a proper progress in general. I wonder what the software bill of material will reach. More on the software bill of material, of course, the presentation of Klaas in about 10 minutes. Now, Leandro provided an interesting remark on our YouTube channel, stating that, basically asking why not both. Simply, if we do the physical meeting, we could, of course, we always record them and publish those recordings afterwards, but we could also combine the two and have the physical presentation and the virtual at the same time, leaving people from over YouTube to join and ask questions as well. So up in the comments a new poll: if we were to hold the next meeting both physically and online at the same time, would you either attend it online, attend it physically, or base your attendance on the subject of the meeting? This poll will be up until the end of the next talk, and as said before, the next talk will start about 5 minutes past 8. So if you didn't grab anything to drink yet, do so now. Alright, everybody, welcome back to the OWASP Netherlands chapter meeting. The second talk of this evening is from Klaas Wijbrans about the software bill of material. Klaas, the floor is yours.
Thank you, Edwin. Okay, my name is Klaas Wijbrans. I'm an architect in the Philips Chief Architect Office. In Philips, Chief Architect Office supports all our businesses with standardizing on common tools, common architecture, common technology, etc. And as part of the common technology, we were already looking into more making the technologies that all our businesses use common. When software bill of materials came up, it was essentially a logical extension to connect to that. However, we are hitting some practical situations, I would say, and I'll go into those in the other slides in this talk. Let's start a bit with the why of the software bill of material. Essentially, what happened is that President Biden had an executive order on cybersecurity requiring the nation's software supply chain to be secure. If you look at this executive order, the actual software bill of material is only one part of it. There is more in that one, including to make it easier for companies to disclose towards federal customers, etc. However, the one that apparently seems to get the greatest focus in a lot of the industry is software bill of material. It's not totally new, because already in 2018 there was an FDA draft guidance for medical equipment, which was essentially more an announcement that something would be coming up on a so-called cybersecurity bill of material, and that one would cover both software bill of material and associated hardware, which was security related. And then already essentially we started preparing a bit for it. However, it got accelerated a lot by the executive order, and then you saw a number of different organizations being asked to work on it, with the NTIA essentially taking the lead on defining a first standard for this software bill of material. You could also say that the current state of the industry is evolving, and I really noticed that because I've never had so many new friends on LinkedIn that want to tell me about how I can use their beautiful tooling to create a software bill of material. So apparently it's a big topic for many startups, vendors, etc., and I'm making a lot of new friends here. The other side of it is the customer ask. If you look at the executive order itself, it's about federal agencies procuring equipment or software, or equipment containing software, essentially need to make the software bill of material a requirement. It also puts a big time constraint on it, because after the raising of the executive order, you have 1 year to implement it. So for us, May 22 will be critical for any sales we do to the federal agencies. And for Philips, that's quite big, because that's essentially everything in medical equipment we sell to, for example, the DoD or Veterans Affairs departments, which in themselves are big customers. But outside of that, we see that US customers really start asking for it as well. And though it might not yet be a legal requirement towards them, it certainly has commercial value to have a software bill of material. So it's really a hot topic. Not having it would complicate new products and services from being sold in the US. The reason why it got hot is a number of big hacks, like the SolarWinds, like Colonial Pipeline, like many others, which in the end all culminated in this executive order, putting more pressure on all of the industry, essentially. Well, why? Essentially, the background of the software bill of material is, am I affected by a vulnerability, and where is this vulnerable piece of software being used? And you see a number of the things that came along. And it's not easy, because if you look at our products, we run them on, for example, Windows, we run them on, for example, Linux. But as part of the product, we deliver them with that operating system. We run them on all kinds of embedded devices created by Philips, using operating systems like well, embedded Linux, that's an easy one, but also things like FreeRTOS and other real-time operating systems. Or we combine things with Windows with real-time operating systems like VxWorks. On that, there are often multiple third parties. And what you may find is that you might not be using that piece of software ourselves in our own code, but it is still on the system because one of those third parties or the operating system provider is using a vulnerable piece of software. And you might even find that multiple of them are doing that in different versions in different places, where they link to different versions of, for example, OpenSSL libraries, which may have vulnerabilities, or other kinds of software. And in the end, I would almost say this is the boring job of bookkeeping of what you use in your software, but bookkeeping apparently is not easy. What is it in the end? In the end, it's defined as the inventory of all the software that you use in your product, including transparency on supply chain relationships, vulnerabilities and risks, and license information. And then it applies to all kinds of software, commercial software, where you have a paid license, free software, which is a very hazy category. It's not open source. Sometimes it's software that you get for free from people on the internet. Sometimes it's software under all kinds of freemium models. Sometimes it's also hardware vendors like NVIDIA providing you with their own binary software that goes with the hardware, where you don't pay separately for the software. But without the software, the hardware will not do anything for you. And that's also often classified as free software. You pay for it through the hardware, of course. The same you see, for example, in Wi-Fi stacks, where you buy a Wi-Fi module which has an integrated Wi-Fi stack, and that software is part of it. And then you get into the thin line of when is it software, when is it firmware. You have all kinds of embedded components that contain software in it, where the view might be even more dim on what it's actually doing there. NTIA also standardized on 3 interoperable data formats. One of them we just heard about, CycloneDX. Another one is SPDX, which is essentially driven by the Linux Foundation. And the third one is the Software ID standard, which is an ISO IEC standard. And as a vendor, you also need to decide on those kinds of things. What should we use to charge our customers? And one of our roles as Chief Architect Office is to make sure that we have a common choice in Philips, and that we don't have one product going to the hospital with SPDX and another one is CycloneDX. So they all do SPDX, or they all do CycloneDX, or they even all do both, whatever we choose, but no variation, please, because that will only confuse the hell out of our customers. Then if you look inside the software bill of material, and here I'm just listing the minimum data fields in the NTIA standards, then they talk about things like a supplier name, which they define as the name of an entity that creates, defines and identifies the components. The component name, what is it? The version of the component. Then they have something which you can add like other unique identifiers. And for example, here you can think of identifiers that are used in the vulnerability databases, etc., the CPE, for example. But it could also be other kinds of identifiers that are used to identify that specific software. It could be even the ordering code that you should use to order that software from a vendor. Then there's something called a dependency relationship, characterizing the relationship that an upstream component X is included in software Y. Who is the author of the software bill of material data? The name of the entity that creates the SBOM data for that component. And then a timestamp, the record of the date and time of the software bill of material data assembly. And to be honest, only these last two for us are a bit more trivial, because we know that the author in the case of Philips is Philips, and the time step is the time step of when we do that. But for all of the others, essentially what we already see is challenges challenges in the ambiguity of the standards. Take what is the name of an entity that creates, defines, and identifies components, the supplier name. To start with, supplier names change over time. A company is taken over another company. What do you do then? Huh? IBM acquires Red Hat. Do you change the name to IBM or is it still Red Hat? Maybe even questions like, when can I still consider it Red Hat and when should I consider it IBM? Because Red Hat might now not still be an independent entity within IBM, or it might have become a brand name instead of the supplier name. That's already causing all kinds of difficulties. Suppliers' names can also be problematic for another reason. Often we don't buy software directly from the entity that creates, defines, and identifies components. And to give you an example, we use a lot of software from Microsoft. However, we don't buy it from Microsoft. We buy it from a distributor, and there are different distributors in different places of the world. In the case of Microsoft, everybody knows who the original manufacturer is, but there are often other parts that you might get from a reseller, where it's not totally clear who the original supplier is commercially. And then I'm not even starting about the fuzziness when you talk about open source. Is it the community? Is it the person? How is it defined? What name should you use? Huh? And also, sometimes I have a foundation behind a piece of open source where the community also has a name. Which one to use? The second one, component name, suffers from similar issues. And to clarify a bit on that one, I added some text below about how the standard is looking into that and what they say about these component names. If you go deeper into chapter 5.4 of the, not of the standard itself, but of the one of the previous framework documents, then they say a component is a unit of software defined by a supplier at the time the component is built, packaged, or delivered. And then if you read the paragraph below that, they say, oh, it can be a product, it can be a package, it can be a library, it can be a complete office suite, it can be an operating system. This makes it difficult, because what does that mean for us? We need to find out what the vendor and the creator of it calls the component. And maybe you can see from my examples that I'm not always a friend of Microsoft, but also there it's a bit of a mess. First, to give you another example, in Microsoft they have a component called .NET. That component was intended, or essentially they declared it end of life. It's still present in certain Windows operating system versions as version 4.5 point something. And instead the whole world is expected to move to something new, which is called .NET Core, which then had a version 3 something, which went to a version 5. And which now, instead of being a .NET Core version 6, they renamed back to a .NET version 6. So the component name is not unambiguous. The component name changed even to the name of an earlier component, and now you need to know the version of it to know which one you're talking about. The version, similar story. There is a good standard on the internet called semantic versioning. I would love if every supplier would use it, but I have service packs, I have maintenance releases, I have editions, and so on and so on. And so again, it's difficult to unambiguously identify what a version is. I have Windows LTSC, IoT, Enterprise, LTSC, you need all of that 2019. Yeah? But when I have that, there will be subsequent updates to it. It's not clear how updates are identified. They have a build number, they have other identifications. Which ones are the ones that we should use, according to the supplier, to specify which version it is. And then we have the interesting thing of the dependency relationship, which is characterizing that an upstream component X is included in software Y. But how is included identified? Does it mean that I statically link it in? Does it mean that I deliver it as part of the whole component that I deliver? There's still a lot of ambiguity in this whole standard, which makes it a bit difficult to already start constructing proper software bill of materials. And especially this bottom one was one where we had in our core team looking at this a whole meeting on this afternoon to see, okay, how should we now do this? Because also for us, as Philips, we have to define what do we see as a component. Now, we took a very simple decision. For us, the product is a component, because we don't sell software that the customer builds on top of again, that he has all kinds of variation in. He buys an MR scanner, he buys an integrated CAT lab, he buys an X-ray system, he buys a toothbrush, to make it even simple, because also in toothbrushes nowadays there's software and connectivity. Yeah? So that we made simple. But then we go into how to identify what's in it. Yeah? Because if I go totally tree-based, then I might show the same component multiple times, or can I flatten it out, yeah? And just give them a linear list? Because is it useful for someone who does not know the internal architecture of the product to know that there are certain internal dependencies between some of these packages? So this is an area where I think we'll, as an industry, hit a lot of issues currently while trying to construct these software bill of materials based on this NTIA standards. And to be honest, in terms of standards, quality is not optimal, let me say it that way. Let me go to the next topic, how to create then a software bill of material. Then we have the multiple formats that exist. We had just a whole presentation on CycloneDX, the dependency tracker, which by the way looks like a very interesting tool. We have SPDX from the Linux Foundation, we have Software ID, and you can choose any one of them, but you have to choose something essentially. But in the end, our observation is it does not matter what you choose. Because as Philips, we make products and we have many suppliers. We have hundreds of suppliers of commercial software, a few big ones, many small ones. And in the end, these will have to deliver us their software bill of material for inclusion into our software bill of material when we deliver a complete product. The thing is, we don't know what they choose, so we better be able to take in any of these formats and convert them to one another. This is why the people state they're interoperable. How interoperable they are, we'll find out in practice when we start converting from one to the other. But in the end, it does not matter. If Microsoft would give us CycloneDX and we would decide to deliver in SPDX, it means that we still have to transform it in a way for anyone to use the complete software bill of material. In our case, we have chosen for SPDX based on pragmatic considerations because our available tooling was partially supporting it, especially in the Linux area. It was part of our build pipeline already. For the others, we need to work on those still. We have no preference. It's more a pragmatic way, and in the meantime, we'll wait out which ones get the most traction in the market and convert to the best one once it's stable. And maybe it will never get stable, and we will just stick with a choice. Then we have the issue of the standards themselves, and I see I have an issue with this slide. But the standards themselves are still evolving over time. What I showed in terms of data elements was the minimum defined, and if you look at the first requirement for May, essentially the government just asks for those minimum elements and only the first level of dependency. So not recursive, not totally in-depth, etc. And to be able to do that, they allow you to say for a dependency that it's a known unknown. And trust me, we will have a lot of known unknowns. The thing is that if you look at the whole document and you see what in the end they plan to do, there's a lot more. Because there's a whole part which is now exempt, like cloud and SaaS. The initial release is only for the really physical type of products. There are things about integrity, authenticity, and I think these are key. Verifying the components and confirming that they were not altered. Not only from us, but also from our suppliers towards us. And especially, how can we really start doing that properly for open source, where many people have access, and it will depend on the strength of the community, whether malicious actors would be able to insert malicious code or not. Things like vulnerabilities, weaknesses, risk information, which also will have to be added. Things like exploitability on the roadmap. It will evolve a lot. There are more things like there are also like hashes to identify with the software component, and many more. An additional complication there is that there are multiple parties involved. The NTIA was the first one who started defining the minimum elements of the software bill of material. The NIST identified to which systems it would be applied, because initially it applies to systems called critical infrastructure in the US. And one of the statements we found from that is that healthcare systems are considered critical infrastructure. So, question answered. Then we see a new agency coming up, the CISA, Cyber Infrastructure Security Agency. The Alan Friedman, that the previous speaker also mentioned, moved from NTIA to CISA, for example. We expect that the standard will evolve further by one of these agencies. Then another thing we see is the FDA. FDA already in 2018 started with cybersecurity for medical equipment. They are also working on making it mandatory. For us, that's also a danger, because a lot of people in Philips know FDA and know that they're relevant for a pre-market submission, so when we bring a product to the market. And as a result of that, they think that this is a one-off activity, which is not correct, because in the end, if you look at the software bill of material, essentially with every update of your software you provide to a customer, you have to be able to provide the software bill of material to that customer again. So he always knows what is running on his system as it is installed at his location. FDA is in practice seen as an entry into the market, more a one-off activity, instead of something that will have to be continuously updated with every release that you do towards customers. And then you get to the practical considerations of also like, and how do you then distribute that to those customers, which also requires forms of standardization. One of the strengths of the SBOM is that they have required a machine-readable format. CycloneDX is machine-readable, SPDX is machine-readable, Software ID is also machine-readable. And there is a thought behind that, but I'll get to that in a later slide. And then the last logo I put in is the IMDRF, which is the more about the medical regulations, the medical device regulation in the whole medical industry. Why did I put on that one? Well, this now started in the US with the executive order that really accelerated it. But if you look at Europe, cybersecurity is also already part of EU MDR requirements. Europe has a different way of mandating these kinds of things than the US does. But in the end, we hope that we can converge on a number of common standards that will give us what they call the presumption of compliance with both of them, so that we don't have to do different activities dependent on who we deliver to. Yeah? And this is also at the same time the problem that we have with all these many standardization agencies being involved. Right now they are not fully aligned in their own terminology, and that makes it difficult again on how to influence what to deliver to who. And it's sometimes not even clear who is in the lead for what yet. Oh, wrong button, sorry. Then I want to get to tooling. And what I liked about the previous speaker is that when you have an SBOM, the problem is, in many cases, you don't have an SBOM. It does not come automatically out of your build system. It's highly dependent on how you configured it, how you set it up, how you integrated all kinds of tooling in your DevOps environment, which build manager you use, Maven, Gradle, whatever. They all need different ways of configuring. How you include third-party and open source in your build tree, whether you can detect it easily or not. If you set up your build environment and dependency management very well, you can get most of the input from your build itself. But never easy, because many of our products consist of multiple technologies. We have technologies for more the back-end services, we have technologies for user interfaces, using different languages. And for each of those you will need to be able to have this. So a lot of variation. Then we have the tools that were mentioned, like the code analysis tools. Also there, detection of correct packages. It's an issue. In Philips we were using, we're still using, I should even say, Black Duck from Synopsys. But we were having a lot of trouble with false positives from the tooling, also incompleteness from the tooling. Also what you see in many of those tools is they focus mostly on open source, or they focus on commercial, but very few focus on both. If you have open source, you very often see loads of false positives. It even came to the point that our research organization has created a number of example open source projects, and I think they're even available somewhere on GitHub. I don't know the links myself, that we were using to essentially evaluate the correctness of our tool vendor. So we not only use Synopsys, Black Duck, we also use White Source as a second check to check the check. And we were evaluating many different kinds of open source tooling. And on a positive note, open source tooling is really accelerating at the moment. Then we see that people like GitHub are trying to include additional tools to detect packages. We see that Artifactory X-Ray is trying to do that. And so in the end, we might end up with too many inputs that are all inconsistent. And how do you then deal with that? And especially, how do you get rid of all your false positives? Because each of them either gives you a false vulnerability if you're not unlucky, or it results in manual work. One of the other things found is that it doesn't matter which of those tools you have, there is a learning curve. It takes effort and knowledge to set up the tool correctly. And that requires people who understand open source and build processes and software engineering itself, and they are scarce. You don't see the combination that often. Another very important one that we found is effective integration and automation with CI/CD pipelines. And what I especially see in many of the startups is that they come to us with beautiful web interfaces. But if I can make a very blunt statement, web interfaces are meant to sell it to management, but not usable in a real CI/CD environment. We need to have integration, automation, APIs that you can do that. We also found that often the sources that they have and the data provenance are hidden in the tooling. And you have to start challenging with your vendor and make sure you get it out of it. And we find that internal and proprietary packages often need special handling because they will not be in their database. They're not publicly available, so they cannot know them. And one of the things we found in the default setup of Black Duck is that if it didn't know it, it ignored it, which is not that good because then you might have a lot of software because it doesn't recognize it. Though they have a huge database, they are not complete. I think nobody is complete because there's too much open source in the world. So also there, tooling really is a challenge still when you want to create these software bill of materials. And in the end, until now, manual review is still always necessary. Then the last one is we should not forget tooling at the customers. And this is one that we're really a bit afraid of as well, because we see many startups and established companies starting to scan products and scan them on the binary level. And if you're unlucky, they'll detect based on a few signatures, or they'll flag everything they don't know, and that could result in huge numbers of false positives. In two ways: one, because they don't detect things correctly, or number two, because the component may exist on the product, but the vulnerability is not relevant in the context for that specific product. Then we are seeing practical challenges, and just to start with volume. And these images are not very readable, but what you see is the number of unique software components that we were encountering in Black Duck. And for your information, we ask people for their key technology list, and that's the upper line, the 150, 225, 290 in 2020. I also asked what the current status is. We're now in the beginning of 2022, and we are at about 600 key technologies. And below that, you see how many dependent packages in the end we have pulled in. And we went from 15,000 to 20,000 to 35,000 to now about 100,000 different open source packages. And these are really different packages, not different versions of packages. They're really different open source packages. To put this in context, 100,000 is significant. It's a lot. If we look at the total commercial, I think we will encounter about 1,000 components, let's call it that. But at the same time, what we were already hitting is managing this at scale. Tools get slow, databases are not really initially meant for these kinds of sizes. And how can you manage these at scale? Also, if you look at products, right now as Chief Architect's Office, we're tracking about 140 active platforms and products in Philips. That excludes all the things we're still selling, but which are more or less in maintenance mode. So scale is really starting to become important for an enterprise as Philips. Because in the end, we need to know for each product, at whatever customer it is, what the software on that product is and what the associated vulnerabilities are for that product. Another interesting topic here is the other risks we are managing. As you can see, we have three other boxes here. One is on open source license risks. And open source license risk is a really tricky one. There are a number of well-known licenses. There are also loads of open source with funny licenses, I call them. People who themselves created a license by stating that they didn't create a license and things like that. And every time our legal needs to look at that. We have other risky things in open source licensing. There are a lot of people who take a well-known license, take an LGPL v2, which is considered safe, but instead of including the license in their software, in the header files in their software, they put in a URL referencing the Software Foundation site with the licenses and then the LGPL license. What happens? That license nicely points to LGPL v2 at the time of the creation of that open source software. But now it doesn't point to the LGPL v2, but to an LGPL v3. And that's nasty because the patent clause in LGPL v3 and GPL v3 as well, by the way, is different in such a way that our legal considers the one acceptable and the other not acceptable. So while the open source is not changing and not changing any of the text of its license, the link they're pointing to is changing from something which would be favorable to something which is not favorable anymore. And that's tricky. With licensing, there are way more tricky things. To give another example, I take open source package, for example, an RPM package from the ecosystem. In there, I might see a license. But if I look in the package, I might see a license file. I might also, if I look in the package, find source files with headers which mention a license. They are not always consistent. It's not clear which one you should in those cases use. Probably unless the community is a strongly governed community with its own rules stating that whatever we do, we deliver under license X, Y, or Z. It could even be that people try to poison your license by adding code where they claim a different license in the header or in a different copyright. And if you don't have a strongly managed community, it might become a risk. These are other things that make even something that sounds as simple as what is the license of that software not simple. Then if I get to more my current headache, vendors getting their software bill of material info. What do they define as the component? And to give you again the Windows example, we use Windows 10 IoT Enterprise and then a different LTSC in our products. And we're now just at the point of moving to the 2021 LTSC in our next releases of the products. But what is the component? Because that's the decision of Microsoft. Is it the whole operating system? And should we ask them for an SBOM identification for the whole operating system? Or is it more granular? And why is that important for us? Well, because we harden it. And do we have to take the whole operating system into account and get all those vulnerabilities and then for many of those just state this component is not part of us, cannot affect us, like Steve was showing in the previous one? Or is it in certain different subcomponents where we can just put in our own software bill of material, we only use X, Y, Z, and now we only need to look at the vulnerabilities for X, Y, and Z. Well, another issue we have is naming. You might think the name of the component is easy. We checked our top 13 vendors where we're spending the most money with and that we're using the most money software from. 8 out of them have not defined proper naming or versioning. Instead, when we order their software, what's in the contracts is a description of the software. There is no name. Some of them we know. And one of them, by the way, is a certain speech engine vendor that has been acquired by Microsoft. They change the naming every year. It's a marketing thing that they do that. How can you keep that up to date? What will happen is that we start writing to all those vendors, pointing to the NTIA standard, pointing to the executive order, that we need that information from them. And then the other challenge, of course, will be the contents. How do we get into place that we, for every update, we get their SBOM, that we in a machine-readable format so that we can look at the differences, consolidate it into our SBOM in a timely way, because if it's way too late, then it doesn't help us and it doesn't help our customers anymore. Open source, similar story. How do you deal with the communities merging, forking, moving, being abandoned? open source, which is named after an author, which you cannot find anymore on the internet, and then you find that several people forked it. So who should you use now? Who is then the supplier? And who is the original supplier? How do you manage that? How do you keep track of that? And this is a really dangerous one as well, because you might think that you could use an URL, for example, to a GitHub location. One of the false positives we had in our software was from a community that was not happy that GitHub was taken over by Microsoft. So they moved to one of the other ones. So they were gone. And then we find that a new piece of open software is now present on the same original URL. So how can you properly keep track of all this moving around of communities between different open source platforms, etc.? I think there are a lot of challenges here. And then the last one is frequency. Essentially, we need to share an up-to-date SBOM with every release to a customer. And our biggest worry there is if we start telling them, will that open the floodgates towards Philips, where they start asking questions about vulnerability after vulnerability after vulnerability. To give you an example, I might have my software bill of material disclosed to that customer, and they look in the vulnerability database, and that's already, by the way, not easy, because we might use certain identifications in the software bill of material. In the vulnerability database, you'll find the CVE identification, which is not in yet, because there might not be a vulnerability on that software component at all at that moment in time. So you don't know what that will look like. But if you're lucky, you'll be able to sort that out. And then you'll find that there are quite a number of vulnerabilities. And especially my nightmare is the Windows 10, which is huge, which is a target for almost the whole world, because its use is huge, so it has a very big target painted on its back. Loads of people trying to find vulnerabilities to hack it. And then people would start asking us questions, because we use Windows 10 IoT Enterprise, and that's the level at which Microsoft discloses its SBOM and its vulnerabilities. And for that, the thing we really are already picking up now is VEX, which was also mentioned by Steve. So that instead of delivering the SBOM, which is the minimum requirement, we will deliver the SBOM and the VEX to the customer. So that we already can weed out all the vulnerabilities that will not affect us, because they are not relevant for the subset of that component that we use in our product. Why do we see this as so dangerous? Well, because there are tools like Dependency Tracker, and there are many vendors looking into that. One of them we are working with already in our proof of concepts, where we deliver the SPDX and the VEX files, because they will read it in for the whole landscape of that customer and generate reports of all the vulnerabilities they uncover in each and every system. So if we don't combine it with the VEX, there might be a huge stream from all kinds of automated tooling from all kinds of customers, resulting in loads of vulnerabilities, and all of them knocking on the door of Philips. Hey, what about this vulnerability? What about that vulnerability? Well, then especially combined with the danger of delays we see with parties like the many different suppliers, where you also need to get their new SBOM in time. This could cause a huge stream of questions. That essentially would be wasteful for us and wasteful for the customer. And that's why we really think the VEX side of it requires at least as much attention. So that in the product tree of our product that we deliver to the customer, we can indicate, hey, for version X, it's known affected and we have a remediation, but for version Y, it's known not affected. Here is the example, the log4j package. And with that, yeah, I'm at the end of the presentation, and the floor is open for questions.
All right. Thank you, Klaas, for your presentation on the Software Bureau of Materials. Again, if anybody has questions, please leave them in the comments and I will relay them to Klaas. Still applies to the previous presentations as well. Now, the results of the second poll. The question was, if the next meeting were both physical and online, would you either attend it online, attend it physically, or choose that based on the subject? And, well, there's no clear majority, but the most popular option was choose based on the subject. Based on the results of these two polls, the next meeting will also be held online, and we'll look into the option of combining them for the month of May. While we're waiting for any comments to arrive, let me remind you that we have two different larger events coming up, and these include the OWASP Virtual AppSec in June, and this virtual event, of course online, will replace the yearly large physical conference OWASP has. So this time it will be online, held in June. The early bird registration is now open. If you like to know more, go to virtual.globalappsec.org. A bit closer to home, and a bit closer in date as well, is the OWASP Benelux Day. The OWASP Benelux Day, usually held in the last week of November, is this time in the last Thursday of March, the 31st, as well as the 1st of April. It's held in Belgium, in the town of Kortrijk. If you don't know where it is, well, use Google Maps. Basically, it's close to the border with France and relatively much to the west of the country. The topics can be found online on www.owaspbenelux.eu. And we have a question from one of our viewers. Anthony Harrison asks, do you produce a software bills of materials for legacy projects which are still under maintenance support? Klaas, what do you say about that?
We are prioritizing first, and let's not forget what I mentioned, that we have about 140 products that we currently actively track, and we need them already in May. Standard also took some time to get complete and usable, so we have limited time. So we now prioritize first on all the products that are going to be released and relevant for US customers in May, which is certain types of healthcare customers. After that, we'll expand into all the new releases. Then based on that, we will look at whether we will backport to existing products and when. And that will probably be a case-by-case decision, dependent on the status of the product. And we still have, and that's something to be aware of, the products that we have in hospitals often are used there for 15 to 20 years. We cannot force customers to upgrade. And many of them are not officially serviced anymore. They don't have service contracts, but we still have a legal obligation to provide them with certain updates. So in the end, for those, it's mostly restricted now to safety updates, because if they don't want to upgrade and it's a product running on a Microsoft Windows release that's no longer supported by Microsoft, yeah, we can help them mitigate. We recommend them to put it behind the firewall and take all kinds of other precautionary measures. But it's no longer possible also for us to do any updates to those products anymore. And for those, we wonder whether it would even be relevant to still produce a software bill of material, because from a security point of view, I think you should say it's broken, you should have upgraded already.
All right, thank you for this answer. If there are any more questions, please let us know. Use the comments. And actually, we already do have another question. Hans Paas asks, is there any progress on software bills of materials and CVE management? You aren't allowed to update the software bills of material for release. Should CVEs contain the SBOM reference?
I think it would be good, and I'm not sure how much. Let me first make a disclaimer. I'm not a security person. I'm driving this standardization in Philips. So I don't probably know enough about the CVE management side. What I do know is that we are looking into multiple things on software bill of materials. And the software bill of material, in our view, is static for the delivery of a release. CVEs are dynamic. Yeah? We need unambiguous identification. I think it would be good if we could come to a more common standard on how to identify components as part of the software bill of material, including the big top-level components, for example, like our product, which also can have a vulnerability. And indeed link those to the vulnerability database. But right now, I don't think there is a mechanism for unambiguous identification. If you look at not the NTIA minimum requirements, but the multiple workshops they had before that, it's really seen as identification as a hard problem to get solved. Maybe not because it's not possible to define a good standard, but because there is no way currently to enforce a good standard. Partly we might suffer from that as well, because we will ask our suppliers, but not all of them deliver to the US government. So how can we even convince them now, well, we are already using them, to have unambiguous identification? And I think that transformation is what makes it difficult. So I think we would love if the EU would come to a similar statement as wide-reaching as the US, that all software in Europe also needs the same unambiguous identification, because I think that's the biggest challenge there is to get everyone to use it.
All right, thank you for this elaborate answer. Last but not least, Klaas and Steve, thank you very much for your presentations on this subject. Recordings will be published afterwards. And of course, as well, we have 2 new projects. Don't forget them. If you missed that part, you can scroll back to the start of this meeting and view them again. Now, the next meeting, as I said, will be held online as well on the third Thursday of April, which is the 21st. Online, and details will follow later on. If you want to attend, please follow us on the OWASP website, as you can see in as you can now see in the screen. Thanks all for watching. and hope to see you again next month.
About